going to talk about circles, circumference, and area. Circles, circumference, and area. Taking a look here, please make note of the date and time that you are watching this video, as well as your location. The date and time as well as your location. It says right here that the diameter of a circle is 60 inches long and, need the word bisect there, bisects a chord of a circle which is 48 inches long. How far is the chord from the center of a circle? So our pieces are, we have a diameter, which is 60 inches. We have a chord, which is being bisected, which is 48 inches. And we're being asked, how far is the chord from the center of the circle? So let's get those on the diagram here. We have a diameter. The diameter is 60 inches. Diameter goes all the way across. And it is 60 inches. We are told that it bisects a chord. So it cuts a chord in half. And we learned in the previous lesson that if a chord is bisected, that we also have a right angle. That whole chord is 48 inches. We want to cross stuff out as we account for them, which means if it's bisected, this is 24 and 24 inches. And we have, very importantly, a right angle, because if perpendicular, then bisect. We're asked to find how far is the chord from the center. That's a distance, and we learned earlier that all distances in a circle are actually a segment. Now here, we can't really solve anything at the moment until we have ourselves a triangle. Remember, you can always draw in and add extra radius, or radii, plural, because they're all equal. Now, if we draw one there, that doesn't make a right triangle. But if we swing one around here and connect it to the chord, now we have a right triangle. That radius is half a diameter, so it's 30 inches. We have this part of the chord, which is 24 inches, and then we have the unknown distance from the center, which is x. We have two sides of a right triangle, so we're going to use Pythagorean theorem, leg squared plus leg squared equals hypo squared. We're going to end up with 24 squared plus unknown squared equals 30 squared. So x squared equals 30 squared minus 24 squared. And then we square root both sides. So our final version is x equals the square root of 30 squared minus 24 squared. At this point, we'll get our calculator out. We have 30 squared minus 24 squared. That equals 324. Then we square root, and we get 18. Inches. All right, so what are we learning about today? We're going to talk about circumference and area today. Circumference and area. We see here different circles of different sizes. Different circles and different sizes. I'd like you to trace the circumference. So trace the circumference, and then trace the diameter for each of these. Trace the circumference, trace the diameter, trace the circumference, trace the diameter. All circles here have the same shape. They have the same shape. All circles are the same shape. Unlike triangles, triangles can have different shapes. You can have a right triangle. You can have an equilateral triangle. So that's an example that triangles that have different shapes, but circles by their nature will always have the same shape. They just vary in their size. They have the same shape, but they have a different size. Same shape, different size. That should ring a bell from something in the past. That defines similarity. Same shape, different size. That defines similarity. So put the similarity sign between all of these. All circles are similar, which means they have the same shape, but they have a different size. Basic definition of similar, we use the acronym SCARE. SCARE, similar, similarity is congruent, angles, ratios equal. So all these circles are similar. They're going to have some sort of equal ratios going on. There's a particular ratio that we're going to look at today. There's a very special ratio in a circle in which we divide the circumference, which we have in blue here, by the diameter. And since all circles are similar, this ratio will be equal for all circles, regardless of their shape. This ratio will be equal for all circles, regardless of their shape. Remember, a ratio is just something over something. That ratio that we're going to talk about today has a very special name. When you take in a circle the circumference and we divide by the diameter, that ratio has a name. That will be the same for all circles, that ratio, circumference divided by the diameter. It is consistent, and it's what's called an irrational number, which means it never repeats and never ends. We use the Greek letter pi for this number. You're probably familiar with pi 3.14, and then it goes on and on and on. Supercomputers have pi calculated to over 1 million digits, but in those 1 million digits, it never repeats and never ends. That's why we call pi irrational. Pi is an irrational number. So we have here circumference divided by diameter equals pi. Now, if we want to get the circumference all by itself, which is the way we usually work with this, we're going to divide or times both sides by the diameter so that we can see with the circumference by itself, it will equal whatever the diameter is times pi. This is the most common equation that we are going to use today. So we have learned circumference equals diameter times pi, or because diameter is made up of 2 radii, you might be familiar on an SAT test that it is 2 pi r. 2 pi r. This will be the preferred equation for circumference, although 2 pi r is what is found on SATs. They are both exactly the same. There's another equation you need to be familiar with, and it is the area of a circle. The area of a circle uses the radius. So trace the radius. And to find the area of the circle, it's easy to remember this because area is a 2-dimensional concept. It is length and width. And whenever we have a two-dimensional concept, things are going to be squared. So how do you find the area of this whole shape? I'm going to shade it. The area, we're going to square the radius. Put parentheses around it. And we're going to times it by pi. That's pi r squared. Now it's very important you put parentheses around the radius because area does not equal pi times r and then squared. This is a no-no. You want to circle that. The parentheses around the radius only. You only square the radius, not pi. Square the radius, then times pi. So the preferred version is pi parentheses r squared. Now to help you remember these two equations and not mix them up, we have a song. I'd like you to write C equals d pi. That's circumference equals diameter pi. And then area equals pi parentheses r squared. Pi r squared. The song is not original. It was devised by students from 2007, so thank you to Courtney, Laura, and Megnan. I will sing it, and you will write it out. It goes, C, d pi, I see d pi, C, d pi, I see d pi. Apple pie is really, really good. Apple pie is really, really good. Now, if that doesn't make sense to you, let me write it out a little bit more detail. It is C, d pi, I see d pi. That stands for circumference equals diameter pi. And then apple pie is really, really good. That's why we square it. Apple pie is really, really good. So I'd like you to get a beat and actually sing this with me. Get a beat. Snap it out. And sing. C, d pi, I see d pi. C, d pi, I see d pi. Apple pie is really, really good. Apple pie is really, really good. Let's put these equations to the use here. I'd like you to take a look at your calculator and locate what's called the pi key. Locate your pi key. If you have a TI-30, you actually have a pi key that is visible right there. Look very closely. See if you can't see a key with the pi symbol directly on it. Those of you using a large TI-83 or 84 calculator, pi, you have to hit second function. It's right above here, the little caret. That's where pi is going to be. So for that one, you first have to hit second function and then find the caret, and that will give you the pi key. If you do not have a pi key, when we utilize pi, you can use the shortened numerical version of 3.14. And for our use and purposes, that is accurate enough. If you were launching satellites into space, you would need to take that out several hundred digits for precise accuracy, for precision's sake. But for our use and purposes, you're welcome to use 3.14. Now, there's two types of answers when we're working with pi. There's something called the pi form and without pi form. With pi and without pi, and you need to get used to both versions and versions of expressions. Let me give you an example. Here we have a circle, and we're given the diameter. We want to find both the circumference and the area of the circle. We want to express our answer with pi. That would be considered pi form, where we leave the symbol in the answer, and without pi. That would be called the decimal form. So here our diameter is 10 meters, which means our radius is going to be 5 meters. And then our radius squared, 5 squared, is 25 meters. So coming down here, diameter is d pi. I see d pi. So Here, our pi form is simply going to be diameter, which is 10 pi meters. Circumference equals. And you are done. That is called the pi form of the equation. Or if we multiply pi in, you bring up your calculator, we take 10 and we times by the pi key. And you may take this to the first decimal, 31.4. And then if you're given any kind of units, you must include units in your answer. Now, area is pi radius squared. So for us, the area, that r squared, we already have it. It's 25, so we're going to bring this and plop it right there. So the area of this same circle is simply 25 pi meters, and because it is an area, it is meters squared, not just meters. That's the pi form of the area of that circle. And the non-pi form is going to look like this, 25 times pi, and that's 78.5, or 78.5 meters squared. Let's do another one. In here, our diameter is 15 meters. Our radius is going to be half of 15, which is 7.5 meters. And then we want to get radius squared, so we do 7.5 and square it, we get 56.25. 56.25 meters squared. Whenever you square something, the meters become squared. So our circumference, which is d pi, our d here is 15. So our pi form answer is 15 pi meters. Or we do 15 times the pi key, and we get 47.1. That's the circumference of that circle. To get the area, it's pi r squared. Area equals. We already have the radius squared right here. So it's going to be 56.25 pi meters squared. That would be the area of that circle. If we wanted the decimal version, 56.25 times the pi key, we get 176.7. And again, it's meters squared. I would like you to stop the tape and attempt to do this last circle completely on your own. Take you about 3 minutes, then start the tape again and check your answers. Let's check your answers. In this case, our diameter is 6 meters, which means our radius, trace it, is going to be 3 meters. Our radius squared is 3 times 3, so it's going to be 9 meters squared. When you square anything, the units also get squared. Circumference is c d pi. So our diameter is already 6, so our circumference here simply equals 6 pi meters. The decimal version would be 6 times the pi key, and that would be 18.8 meters. Area is apple pie is really, really good. We have here our radius squared is already 9, so it's 9 pi meters squared. So we go 9 times pi, and we get 28.3 meters squared. Now you know how to find both the circumference and the area with the pi form and the decimal form. Let's try our hand at 2 more complex word problems. like you to finger track and read this problem. Then we're going to follow this list right down here. Highlight, underline, draw, label, list, cross out, squeeze a sponge, and ask ourselves, what can we do, not what should we do? So it says, if a wheel is 24 inches in diameter, how many revolutions will it take to travel 100 feet? So that's our key information. So we just highlight. Now we're going to draw, label, and list information. First off, we have a wheel of sorts. What do we know about the wheel? It's 24 inches in diameter. Be very, very careful with units. Make note that there is a change of units here. Diameter. We're asked how many revolutions. Revolutions is the turning of the wheel. Will it take to travel 100 feet? So our distance we actually want that wheel to travel on is 100 feet. Draw, label, list, and we cross things out. Now we ask ourselves, what can we do? Now the first thing we have to account for is whenever you have discrepancy in units, you must get the units to be in the same unit of measurement. So either we need to take here inches and translate them into feet, or we need to put feet into inches. I tend to default to going in from the larger into the smaller. So we're going to take 100 feet and we're going to convert it to inches. So for every foot there's 12 inches. So 100 times 12, I have 1,200 inches. Now let's ask ourselves, well, what else can we do? Well, let's trace that word revolution. And let's take that word revolution and actually trace it around the wheel itself. There would be a revolution. As the wheel turns, it revolves like this. Look really carefully. That word revolution is actually an undercover word for circumference, because we just traced the circumference here. So let's find circumference, which equals d pi. Our diameter is 24 inches times the pi key. We're going to go 24 times the pi key. For every revolution, that wheel is going to travel 75.4 inches. Every time the wheel turns, it's going to roll along the circumference. So for every turn of the wheel, it's going to cover 75.4 inches. Well, we have 1,200 inches to cover. So we're going to divide one revolution, which is 75.4, into 1,200. We get 15.9, so approximately 16 revolutions is necessary in order for that wheel to travel 100 feet. Let's try another problem, one more. We're going to finger track, read, highlight, underline, draw, label, list, cross out, squeeze a sponge, and ask ourselves, what can we do? So we have a rose garden consists of 2 concentric circles, with the central circle filled with roses and the outer circle creating a pathway around the garden. The inner circle has a diameter of 10 feet. The outer circle has a diameter of 18 feet. What is the area of the pathway? Let's see if we can't draw this. First off, we're going to start with 2 concentric circles. So we have an outer circle. And then we have an inner circle. That's what the word concentric means. Concentric means to share the same center. Now we're told that the central circle is filled with roses. So we have a circular rose garden. So I'm just going to stripe this to represent the rose garden. So we have roses here. And the outer circle creates a pathway around the garden. So this outer circle is creating a pathway of sorts around the garden. Maybe it's filled with pebbles or sand or pounded dirt or something of that nature to create a pathway around the garden. We are told that the inner circle has a diameter of 10 feet. So all the way across through the center is 10 feet. That's the diameter here. And the outer circle has a diameter of 18 feet. So from here all the way across is 18 feet. We want to find the area of the pathway. Now, rather than stay focused on what we're ultimately trying to find, let's ask ourselves, what can we do? We have circles here. Let's pull them apart. We have an outer circle and we have an inner circle. And the inner circle has a diameter of 10 feet. The outer circle has a diameter of 18 feet. What else can we do? We can find the radius. That's easy. This is 5 feet and, of course, 9 feet. What else can we do? Well, we could find the circumference and we can find the area. Area would probably be helpful. So the area here, you want to square the radius. 81. Area equals pi r squared. So that's going to be 81 pi feet squared. And this one, r squared equals 25, so area equals pi r squared. That's going to, area here is going to equal 25 pi feet squared. So what we have here is a donut. If we want to find this shaded area, this area here, you can see that the red fits inside. So if you find the red and subtract, you'll get that pathway. So we have our outer, which is 81 pi. We're going to subtract our inner, which is 25 pi. So we're going to do 81 minus 25. That's going to be 656. So the answer is 56 pi feet squared is the area. And then if you want the pi form, it's going to be approximately 56 times pi, 175.9 feet squared. That's going to be the area of the pathway.